So welcome to this talk, API tips from the Frontline. This talk will not cover the very basics of what REST is. This assumes that you already know that from other introductory talks or tutorials you may have read. So this will build on top of those and provide some more practical examples. The objectives of this talk. Well, I've built many APIs and I made a lot of mistakes along the way, mistakes that I've since corrected. And I want to make sure that you don't repeat my mistakes so that then you don't have to refactor everything halfway in. I also want to help you overcome some common obstacles, because when you start building an API, what happens is that you run into these common hurdles and you're not quite sure how to deal with them, what's the best practice here and there. So I want to help you overcome some of those. And I want to help you build elegant and pragmatic APIs. So I'll cover a lot of topics, so I won't go too deep into the implementation. At the end, I will provide some links for you to look at for some more implementation ideas, but I won't cover too much of that here. This talk will focus on things like performance, security, testing, architecture, and so on. About myself quickly, I'm Filina from Canada. I do project rescue, and I develop, I train, I speak at conferences. And that's pretty much it. Let's talk about endpoints. Basically, it's what URL to call when. So you want to get some data, what will be your URL? And I mean, the answer is really, it's up to you, but it helps if you follow a standard. You can follow someone else's standard, which can be helpful, but then you can also adapt it to your needs. Or even you can come up with your own standard, but at least stay consistent inside your own application and across your APIs. Otherwise, if you don't follow a standard, what will happen is that you're going to have to write a lot of documentation. If you write documentation for one endpoint, then it might apply to all the other endpoints because you're following a consistent routing system. So this was going to be somewhat an opinionated talk, and feel free to disagree on certain things. That's fine. Let's talk about lists. Let's say we want to extract a list of products. So simple API endpoint / products, with the prefix maybe API. / products will give you a list of the products that you have in the system. You can also constrain that by categories or any other filters that you want. If you want to constrain, say, by category, you would say, equal games, comma, movies. And that way you can actually have multiple values without bothering with these complex URLs. Just use a comma to separate the two. And category here doesn't necessarily mean that it correlates directly to a column in your database. You shouldn't design your APIs that way. It should always have a meaning for your API, but not necessarily for the database. You will have to do some sort of translation behind the scenes. You can, by default, fetch a little bit of data, and then you can include additional things if you want. So have a more complete data set when it gets back. So let's say we're fetching a list of video games, and we want to include platforms, like is it available on PC, on Xbox, PlayStation, whatever. So we want to maybe have a sub-object there for the product where we'll have the ID of the category, the name, the slug, and maybe even a link to the image, the icon for that platform, so you can then display it in your shop. You can sort. You can sort by, once again, this does not correspond directly to a column necessarily in your database. It's really up to you how you want to sort things by default. Let's say date means that you sort from newest first, newest releases, to the oldest releases. And by adding a minus, you actually reverse the sort. And that's very useful because, one, it's really short, easy to read. And also, you can then use comma to sort by multiple things without having an additional parameter in there saying, sort order, which is verbose, but also doesn't really help you easily have multiple sorting columns. So that's very helpful. And you can paginate, of course, page number 2, page size 100. I would recommend that you always have default values for all of those. So always have some sort of sorting by default, Make sure that you have some kind of pagination so that you never want to show all of the content of your database in a single request. So always have some sort of pagination. You can always, by default, assume that it's page number 1 and page size is, let's say, 25. It's up to you what you want this to be. If you want to have more ideas about how to design your endpoints, you can find some more information on jasonapi.org, and there's a link at the end of the slides. And the slides will be tweeted, so you'll have access to them as well. And you can have things like language, for example, if you want to display your data in multiple languages. So if your descriptions are different, based on the language, then you will be able to present it in a different way like that. Now, things like language and even pagination can be sent, instead of sending it in the query string, you can also send it using headers. But always think who your end user will be for that API. Is it developers in your company? Are these people you can actually train? Are these people you can support? Or are these just a whole bunch of people out there that you don't have control over? And if you then add this complexity like headers, which doesn't sound too complex, but for some people it is. So having headers just adds a little extra step in the learning curve. And those inexperienced developers will have trouble consuming your API. So if you're going to release it publicly, then simplifying things might be advantageous for you. Let's say we want to fetch details of a product. Simple, just use a slug or an ID, any unique identifier. There's no really a problem to expose these sequential IDs because the API is public anyway. And then you can also include additional details for that product, like photos, like screenshots, let's say if it's a video game, reviews for that product. And the output would look something like that. So if it's a list, let's say we output 2 items with just the name, Skyrim and Civilization 5. I always suggest that you encapsulate that data in a data key. So you have a key data, and under that you put your results. Because I've seen many people will either put it at the root, which is a problem because then you cannot have metadata, because you might want to provide additional information about this request you just did, like how many pages total you have, how many results, so that you can then, when you show the list in the front end, you can then generate the pagination based on that information. And the reason we use data instead of products is it just makes it more standard. So you don't have to constantly, when you try to consume the API, you have to constantly expect a different key there. So you have to guess what it is. It's just simpler to use data. And if you have a single result, when it's a details page, then just put the object under data without the array. Let's talk about verbs. People are used to using get all the time. They just don't think about verbs when they communicate with APIs. So when people send AJAX requests, by default, it's going to be a get request. But the thing is, there are other verbs, and you should use those verbs, because if you use, say, a get verb for a delete operation, then somebody scraping your API would just delete all the objects, because robots are not very smart. So use appropriate verbs that, say, a crawler would not normally send to your API. So then you would post on products to create a new product. You could put or patch on products 1 to update that product. So the difference between put and patch would be put is a complete replacement of the object that's there, while patch will only modify the properties that you send, so only some of the changes, like a diff. So that's the difference. And then you can use delete to delete an individual product. you may have noticed that all of the URLs have products plural with an S, even if when we're talking about an individual product. And this is again for consistency, for simplification, so that you don't have to maintain these arrays of, what is the singular, what is the plural version of this. You just, once you know you're dealing with products, then everything is going to be products. So it's going to be product/1, product/2, whether it's a single or multiple items. And of course, version your API. Some people ask me why even bother versioning, it's just going to evolve. Well, once again, it depends who's the consumer of your API, but even internally, I find that versioning things helps, because then when we want to refactor things, we don't have to change everything, or at least we don't have to worry about having an immediate impact on the entire application. So we can start rewriting parts of the application using the new version of the API. The old parts will still keep working. They'll just be suboptimal. And then when we're ready, we'll move everything onto the next version. So serving multiple versions of your API as your business requirements evolve, as you learn more about the problem domain, your API will evolve. It is inevitable. So version it right away. You can version it using maybe the URL, like /v1, v2, or you can also send it in headers. Depends on who your target audience is, how experienced they are. So you can send the API version inside the headers. Request and response. So how do you format things? There's JSON, there's HTML, XML, all of that. You can, by default, serve JSON, but you can also serve, all of these formats with one endpoint if you want. So let's say we do /products. You can do /products with an accept header, and then you can specify, do you want to receive JSON back? Do you want to receive XML back? Or maybe you just want to receive HTML right away. So you can serve different formats based on what the person who requests the API, based on what they provide in the headers, they will receive a different format in the output. And yeah, you can send other things in headers. When you want to post some data to your API, and I've seen a lot of people make this mistake, they would send their data in the headers. It's not inherently wrong, but if you use something like, application x form URL encoded, that's what you would get if you would just create a normal form in PHP and then submit. Usually you'll see something like that in the headers. And the way the headers are formatted is pretty jumbled, kind of hard with the code to decode. It's hard to read also, like it's not human readable when you want to debug things. So I would recommend instead to use content type application JSON, and then have your payload, instead of like URL encoding it in the headers, instead sends proper JSON in the body of the request. People forget that the request also has a body. Both the request and the response are two sides of the same thing. They have headers, they have a payload in the body, and you can just create standard JSON, put it in the body, with the content type application JSON, and then post it on your endpoint. And it's easy on the other side. You just grab that, you do JSON decode, and it's really easy to work with. And it will look something like that. If you can see it in the back, yeah? So similar to how we extracted data, we saw, there was the data keyword there, and then, the content, the properties of the product. You would do the same thing. So it becomes sort of symmetrical. And it's really easy to write that way, and it's, as I said, it's human readable. So then you would be able to create a new product with that name and price. So posting JSON is quite straightforward, but what about files? How do you upload files? And a lot of people run into this problem early on. I would recommend to use tools because doing uploads yourself can be a bit tricky. If you're consuming the API on the client side, like a single page application or just standard, just some JavaScript libraries, you can use something called plupload or equivalent. Basically, it's done in 2 steps. As you say, drag and drop files onto this widget, it will instantly upload everything to some endpoint that you specify. It will, put the file there, process it, and from there it will return the temporary name of where it was stored. Then you grab that temporary name because you're still in the context of a form, right? You just did the drag and drop. You haven't submitted the form yet, but the file has already been uploaded. And then what you get back is this path basically to the new file. And then you can, when you submit the entire form, you use that value to send to the API. So when you do the AJAX request to save the data from the form, let's say we're modifying a user profile, there's the picture, there's the email address, there's other stuff in there. So you can then combine all of that, send it to the API, and you're done. So you don't actually have to worry about how files are being uploaded to the API. On the server side, you can use something like Guzzle or just curl and upload files that way. So here's an example with plupload. You just instantiate it, you specify the runtimes in the order in which you want them to be processed. So if the browser does not have HTML5, does not support HTML5, it will revert to HTML4 and so forth. And if you want, it's still available, but if you feel adventurous, you can use Flash or Silverlight if you still have faith in those things. And then you specify the URL, and you can also specify the max, size and everything. And the cool thing about this widget is that it allows you to drop multiple files onto it, so multi-upload. You can drag and drop from your desktop. And you can even shrink images on the client side before sending them to this URL. So this URL will be the one that you write to process the file upload. It will be available for you under the files key, and then you can return the path to where you just stored the file. And in the second step, you will actually do an AJAX request to the API. With Guzzle, a bit more code, but it's actually straightforward. You create a new request to a URL, and with Guzzle, you can do everything in one go because the file is already available for you on the server as opposed to the client where it's not yet available on the server. So you can do the whole thing at once. So you create a new request, and then you create a post file, where you open a file and you say, this is what the client's file name should be when it's received on the other end, basically under what key to store it. And then you create the body of the request where you set all the fields you want, the data with the first name and so on, and then add the file there and send it to that endpoint. And this endpoint will then receive the file and can process everything in a single request instead of multiple. Status codes. I've seen a lot of Stack Overflow threads where people say, but my API has specific codes when there's an error, some validation error. How do I send it in the HTTP status code? Well, you don't, because HTTP has nothing to do with your API. The HTTP is a transport protocol. It's really about what happened during the transport. What happened on your application level is a completely different code and should not be sent using the HTTP status code. And I'll show you in a second how to handle those. So everything in 200s means some sort of success. In the 300s, redirect. 400s, client error, means that the person sending the request made a mistake and should fix it, and therefore it will then result in a success. If you get a 500 error, it means something went wrong on the server. Maybe the database is down. Maybe there's a fatal error in the code somewhere. So it's really on the server, and there's nothing that the client can do to resolve that. They just, they should file a bug or come back later. And if you have any API-specific code, send it in the body of the response. So let's say you have a form where you let the person create a new or updates the price of a product. And what you would do if the price is incorrect, it's not a valid price, then you would return the status code 400, which means bad user request. And then in the body, you would have the JSON with all the errors that happened. And these errors can have a message and a code. And that's the code that's used in your API. So when you document your API, you would have like 1001 means that your price cannot be negative or something like that. And has to be greater than 0 because nothing is free. So, and if the user corrects the data, so the user would, this will be forward, these errors will be forwarded to the user. They will see probably like a little message under the text field where they enter the price saying you have to fix this. And as soon as they fix that, they submit the data again and it will save and it will pass. Testing. Testing is actually not very complicated. APIs are some of the easiest things to test. What you do is you leverage the HTTP protocol. Basically, you just send a request to an API endpoint and see what the output is, and see whether the output is the JSON string that you expected to see. So pretty straightforward. And you can use Guzzle, or a lot of frameworks have built-in tools that actually sort of bypass the HTTP and instead use the internal routing component. So it actually saves a bit of the overhead, so you can run those tests much faster. So, I mean, I'm mostly familiar with Symfony, and it does include tools that allow me to not use HTTP protocol. So I can call endpoints directly from the test there. So a Guzzle test would look something like this. Let's say we test the API product. We instantiate a new Guzzle client, and then we send a GET request to some sort of URL. In Guzzle, you would have to disable the exceptions, because if it's a 400, normally Guzzle will generate an exception, but you don't want that because it will affect your test. You don't want your test to have an exception, except instead you want to continue doing your things, and then maybe the status code would be 400 or 404, and you would be able to assert that. So skip the exceptions, send any headers you want, and then you can check the status code, see that this URL resolves in something. Alternatively, you can have another test with product number 9999, and then you will then have assert equals 404, because that product does not exist. And you can also compare the body itself to make sure that the API returned the JSON that you expected it to return based on the data in your test database. So you use something called assert JSON string equals JSON string. Now, why use something like that when you have assert equals? Well, actually, if you use assert equals and you just mess up the indentation a bit, it's not the same string anymore. It's going to freak out. But with this, it won't. And also, let's say your name and price are switched in the output. This method will also be okay with that, so it doesn't matter. And the cool thing is, when something does go wrong, it will actually show you like a diff saying, this is for this specific line, this is what I expected, this is what I got. So you get a much nicer visualization than just these two massive strings perhaps are not equal, and then you have to find the bug, and it's a bit complicated. So really, for testing purposes, if you use JSON, this is what you should do. So when you write tests like that, make sure that you have a separate database for your tests. This database must not change, or as little as possible. It has to be very controlled so that you don't have to maintain your tests. Because let's say you add another product and you then test for a list of products, the output will be different and you will constantly have to update your tests, and you don't want to do that. You want to work on your code, not spend all of your time on tests. And once the tests are done, they should be fixed in time. They should not, the result of the test should not change based on the database. It can only change if you messed up your code. And another interesting thing that a big gain basically that you get from that approach, from that kind of testing, is that you can write those tests before you write any code. You don't have to have any code written. You just write the test, you talk to the front-end developer, you say, well, let's agree on this endpoint, and for this endpoint we will have this output. Can we agree on that? Yes, okay, let's write the test. It's here, great. Now the front-end developer can use that information to start building their front end. So they can basically grab that JSON string, put it in a file, point their front end to that file instead of the API, and they can start building something functional. And you, on the other end, the person building the API, will then write enough code for this test to pass. And when your test passes, you're done. So there is no period where you have to sort of join efforts and make things fit. They will fit because the test will ensure that. And using that, so that test is the contract between you and whoever develops the client application, be it JavaScript, mobile, whatever. And using this approach, I remember I coded a project a few years ago for the United Nations. They only had 6 weeks until a conference in Kenya. And they wanted to at least be able to demo something to the audience. And in 6 weeks, using that approach with another kick-ass front-end developer, we shipped the whole thing in 6 weeks. It was done. There were, and I'm not just saying that, out of nowhere. It's actually 0 bugs. So there were absolutely no bugs in the application. And a few months later, they came back to us for some additional features, but not a single complaint about a bug. So it is a very, very good approach to code the API that way. Authentication, yes, it's annoying. Do you hate coding authentication? Some of you do. All right, the others maybe you don't have an opinion about that because maybe you haven't coded it. Okay, I don't mean to judge. Anyway, so you can have multiple methods of authenticating users, but one thing you should not do is send a username and password in each request. That is the absolute worst thing you could do. Especially if you have untrusted third parties. So you wouldn't want to log in with your third party and constantly hammer them with your credentials. And especially if there's no SSL. Of course, in an ideal world, you have SSL, but in reality, there are some environments that are just so messed up that you might not have any, you might not have enough control over your environment to have SSL. So, yeah, don't send that, because in security, what you have to remember is that you have there's the concept of surface of attack, and by sending the credentials constantly, there are more opportunities for someone to grab a request that contains the credentials. So that becomes more risky. You can have multiple authentication methods for a single API. So you can use one authorized header. If it's not present, then try another type, try another type. So users can actually choose how they authenticate with your API. You can have multiple. And I know that some people might disagree with me on that one, and will probably throw stones at me for saying this. But conceptually, sessions are actually similar to tokens, except that you should, one, use the database to store them so that you can scale it later, so you have multiple servers. Don't use the file storage for your sessions. And also, don't store any session data in there. So just create the session. So use the cookie will become your token, basically. You just use all the automation that comes with it. So you know that a session exists in the database for this user. Therefore, they're fine. They have already logged in. Just don't store any activity of that session. So since the user logged in, you should not say the user has done this action or that action. So don't store any state in it. But if you look at that and you look at how tokens work, you just draw the diagram. Conceptually, they're exactly the same. But other than that, you can use OAuth, OAuth 2, so SSL is required to use that, and you get advanced features like access scope. What is access scope? Well, let's say you want to comment on some blog, and they say you need to log in through Facebook. All right, so it sends you to Facebook, and then you have this message that says, this application will be able to access your email address, your profile, your friends, but it will not be able to post on your behalf. So that is access scope. You don't give them full control over your account, only certain things that you allow them. So access scope comes with OAuth 2. It can be overkill if you just need basic features, like just allow the user to log in. But the cool thing is that you can keep credentials private from the third parties. So it is mostly used when you have third parties involved. Here's an example. Let's say you have those three parties. You have the user, you have the client application, which can be, let's say, some mobile app you're using, and your own application, the API. So somebody is going to log in into your system so some application will log into your system on the user's behalf. So when the user makes a request, hey, I want to see this, the client application will say, well, you're not logged in to that application, so forward you to the login form of that application, so the API. The login form is then returned directly to the user, not going through the client app, directly to the user. And then the user will type in the credentials, will send them once again directly to the API. The third party is not involved in that part of the process. Then the username and password will be validated, because that's where your account resides on the API. It will be validated, a token will be created, and sent then to the third party, the one in the middle, the client app. So the mobile application will then have a token, and that token can be used in the header of all subsequent requests to authorize that request. So the API will see that token and say, oh yeah, that's for this user, and this user is authorized to access this and that, or at least this app with this token is authorized to access this and that, and will be able to respond correctly. It's an extra layer, but it really helps to hide credentials from a third party. You can also use digest. There's a lot more methods like web tokens and whatnot. Digest has its own encryption, and that's good for people who are paranoid about SSL backdoors, and possibly for a valid reason. I especially see that in the financial sector. They don't want to trust the infrastructure. Like, I mean, if there's another hard bleed, all of their credentials will be visible. Digest is now actually pretty easy to implement, because a lot of libraries have that out of the box. Frameworks have that, front-end frameworks have that also. The cool thing about that is you have nonce, which means that you cannot use the same token twice, basically. So even if one of your requests is intercepted and the token is extracted, it cannot be used to authenticate the next request, to authorize the next request, because that one is no longer valid. Once the user completed that part, completed that request, that one is no longer valid. It's only used once. Yeah, the diagram for that is a lot simpler. The user or client application, in that case, you cannot hide it from the third party. The client application will have to have access to those credentials at all times. It will create generate a request. The API will see, oh, well, you're not authorized to access that because you haven't sent us the digest. It will reply with a nonce. So basically like a number that can only be used once. And then the request will, next request, the same request will be repeated, but this time with a digest, which will consist of the nonce and the password. So there's functions for that, and there's a link to an implementation example in PHP, so you actually can just follow the code examples there. And then when the digest is received by the API, it is then processed, locates the user, and authorizes the request. Now, once you see all these APIs, you think, well, maybe I should switch my big application to an API because I want to leverage that. It makes things simpler because we want to build like a lot more JavaScript, in our front end. So how do you refactor to the API? Well, don't rewrite everything at once because most rewrites fail, about 99% of them. A progressive rewrite is where you would rewrite just one component or module at a time. You start with whatever has fewer dependencies on other components, or something that is the most critical, something that has to be moved now out of some legitimate concerns. Once you've done that, make sure you delete the dead code, don't leave it in there. And if you do copy production data to the dev environment, which you should because it's legacy, so you have to have that potentially garbage data so that you can catch all those errors. But when you do that, make sure you remove like credit card numbers, email addresses, and other private data from there. Now, when you start writing things, you can create services like that. And for those services, you can create an underlying library. So, for example, you would have some repository, get API list, and you provide the filters for that. So these two are equivalent, right? You have the products table and then category equal game. All right, so you create something like that, and you have your own logic underneath that. Whatever get API list does in your system is entirely up to you. It allows you to bypass HTTP because you can either use that that line I just showed you inside the controller for that endpoint. So that endpoint will resolve the filters, will generate this request, and that the get API list actually goes to the database and grabs the data. But you can also put that in any other controller where you might need additional data instead of from a controller where, let's say you do like, I don't know, a mailing list, and you want to grab a whole bunch of data about your users, about the products that are currently on special, things like that. So instead of going and requesting the endpoint, which has the whole HTTP overhead, you can just use, get API list directly. So a lot of reuse. So it will also allow you to fetch without pagination because it's the same application. It's a trusted component. It's not something you would allow through the endpoint, but something you can allow within the controller. And the cool thing is that you can hydrate to models. If you're not familiar with hydration, look up ORMs and how they do that. But it's really cool because then you can have an actual model instead of just an array, because JSON will only translate to an array. You can have proper models, and those models can have business logic, and you can do some more fancy stuff. Some implementation tips. So what do? I use mostly MVC frameworks and ORMs. Aside from that, I like small libraries that do not do too much magic, because magic means abstraction, and too much abstraction makes customizing hard. So if I use a library that does a whole bunch of magic, but then I need to do all of the grunt work in the configuration file, I would rather write PHP than learning how to configure this properly and perhaps still not achieve the exact result that I want. So small libraries that do just one thing, that allow me to do most of the stuff in PHP, I would usually go for that. When you write your code, make sure that you streamline the endpoint creation. You extract those request parameters, the filters, the sort, the pagination. You extract them automatically and use that to maybe even automatically generate a query. But make sure that you keep things still customizable. So you need a balance between automation and customization. And if possible, try to decouple your stuff from the framework, because you might want to reuse that in other projects that use other frameworks. Or maybe you will eventually upgrade from an older version of the framework to a newer, and things will break, and the step will be so much that you would just not do it and keep using an old framework that doesn't have any support anymore. Performance. You should benchmark your stuff. If you haven't tried that before, try either Tideways or Blackfire. And then make your performance part of your test suite. So in developer mode, you can have a block like that. So, or rather in test mode, you can have a block like that. So in addition to the data and the pagination, you can return something like this that will say how much time you spent in the database, how much total time the request took, how much memory was consumed, and you can create assertions for that. So if you exceed a certain threshold in the database, you know that you maybe changed the query in a way that now it's taking 20 times more time than it used to. So that is very useful. So you basically, it will result in an error. Hey, this is an error. Yes, your features work, but your database is like really slow right now. So you just made a change that broke it. So go see your query now. So instead of doing that later and trying to figure out what has changed, because you might have a long change log, instead maybe you will be able to spot things, those mistakes right when you make them. Some more performance tips: don't use lazy loading, or avoid it, or use it in a smart way. So when you when you use ORMs, some people, they forget how to write SQL. Make sure you make joins. If you get additional data about something, craft your select statements carefully. Don't just select star. Do select and grab only the fields that you need, because if you're displaying a list with just ID, name, price, then those are the only fields you should select. Don't transfer data that you will not output. It's just a waste. And if your ORM has built-in hydration, if you are just going to extract data and display to the user in JSON, then there's no point in converting that data into a model, which takes time and memory, only so that you can serialize it back to a JSON. So you can just bypass that altogether by using say you're using Doctrine, it will be hydrate array. So you will use that hydration mode. To mitigate DDoS attacks, use API keys even for public endpoints, because then you can disable abusive keys very easily and cut them out. You can even put like those block keys into Memcache or Redis, but you can also use Memcache and Redis for other things like lists that are very common, very frequent. So by blocking an abusive key using Redis, it means you can disconnect those earlier and not waste any processing power on bogus requests. So yeah, I'm actually good on time. Here are some useful links. I will tweet those slides. Actually, the links are the standard API formats that I showed you. So mine is a bit of a modified version from that. How to implement digest directly from the PHP manual. And there's a book you can also read called Build APIs You Won't Hate by Phil Sturgeon. You can buy it on LeanPub. And that is the end of the presentation. I will tweet the slides. You can go to my blog. Every time I find problems, and solutions to them, I will usually document how I found the solution, so you can avoid doing it yourself and just follow the process. Things I tried, what worked, what didn't. Also have some poems there on my site, so that can be fun. And I will take some questions. Thank you. Any questions? Yes. There are tools that allow you to automatically document your API, but those tools usually involve using those tools to generate an API. For documenting it, I could say you can leverage the doc blocks, so you have your controllers. A controller is basically verb plus endpoint, and you can write your documentation in there and grab that and generate a manual out of it. That's what I would do. But usually if you follow a sort of standard practice like that, it's kind of self-documenting. Except if you're doing it for the public. Depends if it's internal or for the wider audience. For the wider audience, you would need proper documentation, yeah. Does that help? Okay. Anyone else? Right. So where should the validation be? The API is your application, really. It's the one closest to your data, and it's the one that should enforce rules. This is the one that should enforce the business rules. If you want to perhaps also validate things on the front end, then maybe you can have different endpoints from which you can expose those rules to the front end instead of rewriting them there. I mean, you don't want to duplicate those rules, but really you will still have to enforce that on the back end, because let's say on the front end you validate something, but I can always just disable the validation or write my own curl request and then send garbage data into the API, and then will be stored in the database. The API is the last line of defense before the database, so it has to enforce those rules. Does that help a bit? Well, maybe we can speak in more detail afterwards. All right, well, thank you very much. I'm out of time. Enjoy the coffee break.